5.3b. Number 1. Find the real or imaginary solutions by factoring. Well, if we look at both of these terms, we see that they're perfect cubes, both of them. So what we want to do is we want to rewrite this as something cubed minus something cubed. Because as it is right now, it's in the form a cubed minus b cubed. And that can be factored as a minus b times a squared plus ab plus b squared. So the first thing is we want to write it in this form. So x to the third minus 10 to the third is the same as this. My a is going to be x. My b is going to be 10. So let's fill in these. A minus b is going to be x minus 10. A squared is going to be x squared. A times b is 10x. And b squared is 100. This gives me a root of positive 10 if I set it equal to 0. This will give me two roots eventually, because this is squared. So this is not factorable. It's not a perfect square trinomial. So let's use the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Simplify this, so negative 10 plus or minus. This is 100 minus 400 is negative 300, all divided by 2. So we can simplify this, so it would be negative 10 plus or minus, extract the I, root 300, all over 2. Now the root 300, let's just break that down over here. That's the same as root 100 times root 3, which is 10 root 3. So let's rewrite this. 10 root 3 times I is going to be 10I root 3, all divided by 2. This negative 10, 10 and 2 can all be cancelled and broken down. So this is going to give me two solutions. The first is negative 5 plus 5I root 3 all over 1. So I'm just going to write negative 5 plus 5I root 3 and negative 5 minus 5I root 3. So we have 1, 2, 3 solutions for the cubic. This one over here, it's a quadratic. It's not a perfect square trinomial or anything special about it like that. So what we're going to do is we're going to use the box method. So we have 6x squared and a minus 5. My AC is 6 times 5, which is 30. If we have all of the possibilities for 30, I'm going to read the signs. Different signs, the larger one is positive. So these are positive, these are negative. The combination that adds up to positive 13 is this one. So I have negative 2x and positive 15x. Let's go around for the signs. This is positive, 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 negative. Let's factor out. We have a 5 here, 2x here, 3x, and 1. So we have 3x minus 1, 2x plus 5 equals 0. This gives me a root of 1/3. this gives me a root of -5/2. Solve by graphing. So let's get the calculator out. So we're going to have x cubed minus 4x squared minus 7x, and then we're going to move this 10 over, so we have plus 10. Just going to take a peek at how it looks here. Alright, so let's get some points. So second table, let's go up a little bit, see if there's any other points here. So -2, 0 is definitely a point that we can plot. Let's just move this over here. So -2, 0. And I'm going to plot -1, 12. So -2, 0, -1, 12. 0, 10, and 1, 0. 0, 10, 1, 0. We have 2, -12, and 5, 0. And the rest are off of the graph. So let's just take a peek at the graph again, just so we have an idea of what's going to happen here. So it's going to go up, go through this point, go down through that point, and then back up again. We could find the relative max here and the relative min here. Let's just see, let's extend the y max just to see how high it goes. So the peak over here is going to be second trace max, left bound, right bound, I guess. So -0.7, 12.5. So it is going to go just a tad bit higher than that point right over there. So let's see if we can graph this. It's going to go up, peak there, go down. It's going to bottom out somewhere down there. We don't quite know how low. And then go up. So there's our graph. We have our zeros, -2, 1, and 5. And those are your zeros. So find the real or imaginary by factoring. So first, get everything on one side. And let's factor this. So let's put the two sets of parentheses. To get x to the fourth, we're going to put x squared and x squared. We need two numbers that multiply to give you -64, but add to give you -12. So we know that there's going to be a different signs, because there's no way you can multiply two things with the same sign and get a -64. The higher number is going to be negative because they have to add to a -12. So for 64, we're going to be looking at products of that. We're going to be looking at 16 and 4, it looks like. 16 times 4 is 64. -16 plus 4 would give you the -12. If I set x squared plus 4 equal to 0 and solve, take the square root of both sides, extract the negative, and then root 4 is 2. So I have positive negative root 2i. This is going to be set equal to 0 also. Add the 16 over. Take the square root of both sides. It's going to be positive -4. So your roots are going to be 4, -4, positive 2i, and -2i. 4 roots for the quartic function. Here's another one we're going to be graphing. Let's Let's move this over a bit. Clear this one out. So we have 3x to the third plus 12x squared minus 3x, and then we move the 12 over, so minus 12. Let's take a look at the graph. Let's just get a regular normal 10 by 10 here. So that's what it looks like. Let's get some points. So let's go to the table. Alright, so we have negative 4 comma 0. Well, let's make this black. We have negative 1 0. Scroll down. 0 negative 12 and 1 0. And then that's it. It just keeps going up. Let's take a look at the graph again. So it's going to go through this point, go all the way up, come down, go through that, go down here, bottom out somewhere down here, pretty close to that negative 12, go up through the negative 12, up through this 0, and then all the way up. So let's see if we can graph this. So it's going to go up. It's going to go up here and then come back down. Whoops. It's not the best drawing in the world. Come down here, come right back up. I kind of missed that 0 there, but that's alright. That's basically what the graph looks like. And we have the zeros, negative 4, negative 1, and 1. So those are your 3 zeros. Graph the function to find the zeros. So this one over here is a quadratic. We're just going to eliminate the use of the calculator for this one, because we know a lot about a quadratic from chapter 4. So here is your y-intercept. So I'm going to put a dot there. I'm going to find the vertex by taking the opposite of b over 2 times 2. So that's my x-coordinate. I could plot that in here. So 2 times negative 3/4 squared plus 3 times negative 3/4 minus 5. So 2 times 9/16 minus 9/4. There should be 16ths here. Minus 5. The 2 goes into 16 8 times, so 9/8. Let's make this eighths, so negative 18/8. Make that eighths, so negative 40/8. So we're going to have a negative 18 and a negative 40 is negative 58, plus 9 is negative 49, so negative 49/8. So 49/8 is 6 1/8. So negative 3/4, comma negative 6 1/8. So it's right around here. That's going to be your vertex. The zeros of it, we could either use the quadratic formula, complete the square, try to factor, see if that works. Factoring, in fact, would work for this one. Let's just bring back the trusty old calculator and get the, just for the sake of time here, you should know how to do this, but so plus 3x minus 5. Hit the table. The table only actually gives us 1 0. It doesn't give us the other zeros. To find the other 0, we could do second trace 2. So the calculator gave us 1 as our first 0. It didn't give us this because our calculator goes up by 1 for the table. So what I'm going to do is I'm going to do second trace 2, which is the 0 function. Left bound is just above it, right bound just below it, and then hit enter. So my 0 here is negative 2.5. So negative 2.5 and 1, and I could get a whole bunch of different other points. Negative 2, negative 3, negative 1, 6, negative 1, 6 over here. 2, 9, another point. So we have a bunch of points to go by here. So let's just do basic. Wow, this is not really going well. Let me just go back. Alright, let me just see if I can hit these points this time around. Not quite on that one. This should actually go through that. So there's our graph. The zeros we found were negative 2.5 and 1. So these are our zeros. And it said rewrite the function in factored form. Well, we get y equals 1 comes from x minus 1. Negative 2.5, remember, that's the same as negative 5 halves. So this is the coefficient of x. We change the sign, and then we put the 5 after it. So that would be the factored form here. Alright, number 7, write in factored form. Well, first it's in order. Second, let's factor any GCF. 2x is a GCF. So we'll end up with x squared plus 4x plus 4. This here is a perfect square trinomial, because if you take the square root of the ends and multiply it by 2, the product of the square root of the ends and multiply it by 2, you'll get 4x. So it becomes x plus 2 squared. So that's the factored form here. Number 8, solve by factoring. You can use the box method for this one. So 15x squared, 6. My AC is 90. Instead of writing 1 and 90 and 2 and 45, let's look at negative 19. We know that the same signs are going to be given. Both are going to be negative. So what adds up to 19 that multiplies to give you 90? That would be 9 and 10. So we know that that's going to be our pair. So negative, positive, positive, negative. Let's factor out. We've got a 2. Over here we have 3x. Over here we have 5x, and here we have 3. So 5x minus 3 times 3x minus 2 equals 0. So my solution's going to be positive 3/5 and 2/3. Number 9. So it's a substitution problem. So 11 times x plus 2. If x is negative 2, negative 2 plus 2 is 0. Am I going to bother with the rest of this problem? The answer is no. You should know why, because no matter what this is here, it doesn't make a difference. The entire numerator is going to be 0, because 0 times anything is 0. I will check down here to see if there's no 0 down here, because then that would be a problem. The answer is no. There's not going to be a 0 down here. You're actually going to get an answer, because negative 2 times negative 1 times negative 3 is negative 6. So I'm not even going to bother with that, because 0 times anything, 0 divided by a non-zero integer or value will be 0 anyway. So the answer is 0. I said 0 a whole bunch of times there. Number 10, which method of solving polynomial equations will not identify the imaginary roots? Explain. Well, the different methods that we've talked about in Chapter 4 and Chapter 5 so far are things like factoring, completing the square, quadratic formula. And these are for specific polynomial equations. Graphing. Of these so far that we've gone over, the one that does not identify imaginary roots is going to be graphing. The reason why is because when you graph, the x-axis intercepts are the ones that represent the zeros of the solutions of the polynomial function. But the x-axis only represents real numbers. So for example, if we have a cubic that looks like this, my graph is only going to tell me this solution. It's not going to tell me the two imaginary solutions that this cubic function has. So graphing is the method that does not identify the imaginary roots, because graphing only shows the real roots due to the x-axis only being made up of real integers. Now there's the possibility of graphing over the complex coordinate system, but we haven't done that yet. And I don't think we're actually going to this year, but you may in pre-calculus.